planes bisecting the angle between two planes. So you have two planes, right? And you have another plane which basically bisects the angle between the u1 and u2. So the angle between u1 and u2, that is bisected by another plane, that is u3. We have to find this equation of this plane. In the previous session we looked at the equation of any plane that has the same or common line of intersection. Here we are talking of a particular plane which cuts the angle between u1 and u2 into two equal parts. u1 is, let's say, r n1 equal to q1, u2 is r n2 equal to q2. Now here r is the position vector of any point on the bisecting plane. The length of the perpendicular from P, let's say this is the point P we are talking of, from P to the planes are going to be equal, right? So here this is a position vector. You take any point on u3, then what will happen is the distance, perpendicular distance, would be equal, yes, from the two planes. Now we know the perpendicular distance equation for that. So q1 minus r n1 by n1, magnitude of n1, is equal to plus or minus q2 minus n2 by magnitude of n2. We have already seen this. Now if we remove the absolute values, q1 minus r n1 by magnitude of n1 is equal to plus or minus q2 minus vector r n2 by magnitude of n2. Now here remember, magnitude of n1 is equal to what? Is going to be a1 square plus b1 square plus c1 square, right? n2 would be a2 square plus b2 square plus c2 square. But in vector form we write it as magnitude of n1 and magnitude of n2. So this is the equation of the plane bisecting two other intersecting planes. Remember, this is very important. What is that? u1 and u2 are not parallel. If they are parallel, there will not be any intersection. If there is no intersection, there will be no angle. Since there is no angle, there is no question of bisecting the angle. Now, if you notice, there is plus minus. That means there are two equations. So, which means that there are two planes. So, what are these two planes? So let's look at it like this. Let's say I have these two planes which are intersecting. So okay. So let's say this is the line of intersection, right? So which means that right, so this is one plane which is bisecting this angle, and this could be the other, right? So basically one horizontal, one vertical kind of intersection, or rather, instead of saying horizontal or vertical, it's better to say there will be two places where the angle between, basically you have two sets of angles. One is this one set and the other set is this. So what does this plus or minus mean? Plus gives the plane bisecting the angle in which the origin lies, and minus gives the other plane, that means which does not have the origin. Now writing the same thing in Cartesian form is quite easy. Remember, we have q1 minus r n1 by magnitude of n1 equal to plus or minus q2 minus n2 by magnitude of n2 vector. This is nothing but your equation of a plane. So that we can write it as a1x plus b1y plus c1z plus d1 by, remember magnitude we have already seen, a1 square plus b1 square plus c1 square is equal to plus or minus a2x plus b2y plus c2z plus d2 by square root of a2 square plus b2 square plus c2 square. And again, positive gives the plane bisecting the angle in which the origin lies, and negative gives the plane bisecting the plane in which the origin does not lie. Okay, have a look at this and understand. The main thing, the only thing that you have to remember here is the perpendicular distance to a point from both the planes would be equal. And you need to remember the equation of that perpendicular distance. Once you know that, rest all is pretty straightforward. Okay, that's enough. Bye for